What's going on, guys? Welcome back to this video. Today we're gonna do some blue teaming on Letsdefend.io. We have a SOC case study. In the case study, one of the users received an email, and the email contains a lot of links, a lot of buttons. The sender of the email offers the users who received the email free Windows 11 upgrades. In order to benefit from that offer, you're gonna have to click on the link. The link redirects you to a site, and the site kind of convincing. The domain name is windowsupdate.com. Now, here is the catch. Windows 11 don't come for free, right? If you have Windows 10, you can then upgrade to Windows 11, giving that your device is compatible. But if you want to install Windows 11 from scratch, from zero, you're going to have to buy a license. Now, this email asks the user that to benefit from the free Windows 11 upgrade, they should click on the buttons and download the executable from the site. Now, here's what's going to happen when you download the executable. The user infected themselves with the Luma stealer, which we have talked about earlier. Okay, let's get started. Okay, so now we're taking over this alert. SOC338 Luma stealer DLL side loading via click fix phishing. Now, if you remember, we have talked about Luma stealer previously, and we analyzed the malware using ANY.RUN. Check out the video if you haven't watched. Okay, so now we're going to take over this alert by clicking on the check mark. By clicking on create case. And from here, create case for event ID 316. Let's proceed by clicking on continue. And now we're going to start the playbook, the SOC playbook. All right, so now parse email. Before starting the analysis, information about the incoming email should be obtained. So now my idea here, my advice is to duplicate the tab and check out the available actions here. So endpoint security, email security, threat intel. We're gonna open endpoint security in a new tab, the email security in another tab, and threat intel along with the sandbox. We need all of these tools to effectively and correctly analyze the incident. Now let's go back. Okay, so here we're asked to parse the email address that we have been sent. When was it sent? What is the email's SMTP address? What is the sender address? We're gonna have to answer these questions. If you go back to the incident, you can see that it was delivered to Dylan at Letsdefend.io. So Dylan has received the email from someone whose SMTP address is denoted by this IP address. So that's the SMTP IP address, which is the IP address of the server that delivered the email to the inbox of Dylan. Okay. The source address here, this is the email address from which the message was delivered. Update at Windows update site. Trigger reason why this alert was triggered in the first place. We see here the IDS or the security solution stated that the alert was generated because the link contained in the email contains a redirected site which contains a click fix type script for Luma stealer distribution. So we're gonna have to now check out the emails coming from this address. I'm gonna copy this and go back to email. I'm gonna search for this email here. And indeed, we have an email address sent from this email to Dylan. I'm going to click on that email address to investigate, and that's the email address. This is the body of the email, and we see it is claiming that this email allows you to, if you click on the button, you'll be able to upgrade your system to Windows 11 Pro for free. It's too good to be true, because Windows 11 can only be free if you are upgrading from an existing licensed Microsoft Windows 10. Otherwise, if you are installing Windows from scratch, you're going to have to buy a Windows 11 license. So that's completely not true. So here, that's the button, update now, and we have another button here, update now, refresh your perspective. You see there are several buttons. It looks like the center was desperate to let us click on the button. See update now in every corner of the body of the email. Okay, you see now if you hover over the email here, on the lower left of the screen, you can see the link here. When I'm hovering the mouse, it is pointing to windows-update.site. You can open this email, you can open the site. See, it's not working, probably because it was prepared for demonstration purposes. But anyhow, that's where the button leads. We don't see any attachment in the email, so we're going to go back here and answer the question. So when was it sent? So it was sent on March 13, 2025, and that's the complete timestamp. What is the email's SMTP address? Now, the email's SMTP address was first addressed in the incident description. You see, that's the SMTP address. The address of the SMTP should be an IP address that, when resolved, points to the domain name. Okay. Now, what is the sender address? That's the sender address, the email. And what is the recipient address? It was Dylan. Is the email content suspicious? Now, based on the description of the incident, it is suspicious. Are there any attachment? No. So having answered all these questions, we're going to be ready now to click next. Now, apart from answering the questions, where did we get the answers? We got the answers by analyzing the email. That's what you have to learn. You have to learn how to analyze the email. Now, basically, when you analyze emails, you can have to go beyond just reading the email and understanding the structure, such as the buttons, if there's any attachments or other things. Sometimes you're going to have to investigate the header of the email. You see here the information laid down here, such as the SMTP address and the source address have been written here for convenience. Now, when you are investigating a raw email, you're going to have to investigate the header in order to fetch these details. Okay. Having this in mind, we're going to go and click next. Are there attachments or URLs in the emails? Please click yes if there are any. If there are an attachment, there is a problem in the grammar here, or URLs in the email. If there are no attachments or URLs in the email, click no. Well, there are no attachments, but there are URLs, several ones, but they're all the same. Can I click on yes? Analyze URL attachment. So you can use the free product services below, ANY.RUN, Price Hotel, URL House, URL Scan. I'm going to use ANY.RUN, and I'm going to have a look at the site. Now here, since the site is down, we're going to have to learn to rely on the database, the threat intelligence database, to see if the site has been submitted or analyzed before. Now we're going to use ANY.RUN's threat intelligence product, and from here we're going to paste the URL and click on search to see if it has been looked up before. I'm satisfied, thank you. I'm just answering to submit quickly. Okay, so no matches. I'm going to use the domain name, and there are, let's see, and we have matches. You see there are 3 domains, and these 3 domains have been previously analyzed using these analysis sessions. And all the analysis sessions state that the domain name is malicious. Now, if you want more details, you're gonna click on one of these analysis sessions, such as you're gonna click on the recent one. Let's have a look at this. Okay, let's navigate through the session. So here, where the analyst tried to reach the site, it wasn't available. And then the analyst, what they did, they inspected the elements, as you can see here. And then here, they inspected the network activity that took place upon opening the site. And what they found here is they are inspecting the headers. Okay, next, let's see what they found. Now, basically here, they're trying to view how to interpret the headers. So going back to the analysis here, let's skip. Again, viewing the headers. So the site was not giving any response. That's typical because it is a demo site. Let's see the verdict here. So it was classified as a phishing site, as you can see from here. Now you can click on the text report to generate a report. And we see here the behavior section states that the site is malicious. And because the behavior was classified as phishing, the responsible process was Chrome. That's typical because the site can be reached only through Google Chrome, since it is needs browsing. The behavior graph, no need for this. Let's scroll down. That's the main process. It was Chrome. Okay. Scrolling down. Let's have a look at the network activity to see if there are any weird or strange URLs that have been visited upon clicking or visiting the phishing site. So these are the URLs, and we can see much of these URLs are whitelisted because they are related to Microsoft. Let's go next. All right, scrolling down to connections. Now the connections can be inspected to see if there is any DNS requests to C2 servers. Now, since the site or the phishing site was not working, we're going to assume that there were no attachments downloaded to the victim host. So since there are no attachments downloaded, it means there are no weird processes running or malicious processes running, and there couldn't be any connections to C2 servers. DNS request, all look legit. Let's scroll down. Fish possible social engineering attempted. Now, since the site wasn't opening, the verdict here was given based on maybe historical data about the domain. Okay, so relying on historical data, it was classified as phishing. So we're going to go back here and we're going to say that this site is malicious. So it is malicious. Check if email delivered to user. Answer the following question by determining whether the email is delivered by looking at the device action part of the alert details. So we go back to the alert details and we click on the device action allowed, meaning the email was delivered to Dylan. So we're going to say delivered. Delete email from recipient. You should delete the malicious email from user's mailbox. Now, why this is? We need to do that because this is part of the eradication and recovery, deleting all signs or all traces left by the infection. Now, this is not a complete infection. Rather, it is malicious activity. Still, we're going to have to delete all traces to prevent further infection down the road to other networks. So we're going to go back to the endpoint security here. We're going to have to locate the IP address of Dylan. Now, Dylan's host is here. We're going to click on this, and we're going to have a look at Dylan's machine. So action, containment, still not contained. We're going to have to delete the email. So these are the running processes, terminal history. Let's have a look at the terminal history here. You see there are PowerShell commands. Browsing history. All right. Now we have a visit to this site. It was on this date, okay, 23:26 p.m. Let's have a look at the terminal history here and look at the timestamps. So at the exact 8 seconds, here we have after like a couple of seconds, 19, 31, 32, we have PowerShell command. Let's have a look at why these PowerShell commands were executed in the first place. So PowerShell-W1 PowerShell command. Now that is the process responsible for executing HTML applications. All right, and then we have overcode, this domain name overcode, pass, light.shop, MP4. This is a connection to retrieve an MP4 file, dash replace, I am not a robot, captcha, and this is submitting the captcha. Okay, then we have execution of an MP4. So here probably what happened, the Dylan, what he did, he visited the site at 23 p.m. exactly at this minute and second. After a couple of seconds, PowerShell commands were spotted to be executed. So basically, Dylan has downloaded the executable file hosted on this site, and upon downloading the executable file, he executed the file that was supposed to be Windows upgrade. And after executing the file, PowerShell commands were executed. All right. Now, let's see here. So we should delete the malicious email from user's mailbox. Let's go now to the emails and delete this email address from here. So we deleted the email. Check if someone opened the malicious file URL. Please go to the log management page and check if the C2 address accessed. You can check if the malicious file is run by searching the C2 addresses of the malicious file. Please click open if someone accessed the malicious address. Otherwise, click not opened. So we were checking if, let's go back. Let me tell you what we did here. Here we're gonna do what we're gonna do. We're gonna check if someone opened these or executed these commands by opening this domain, making a request to this domain. So we're going to make a search using this domain. Also, we can make a search using the file. Okay, so we go to logs, log management, and here we're going to use destination address. So there is no data here. Let's use row log, and contains the name of the file that was retrieved. Now we know for sure that Dylan has opened the file. We want to know if other hosts opened the file. Search. You'll have to remove this. Then refresh the page. Click on row log. Search with the file name. There is a request to this file. Let's see where it was originated from. So the source address is 172 and ends with 216. Probably this is Dylan. Let's go back. Yeah, this is Dylan's address. Okay, so we see other than Dylan, we don't see any requests to the MP4 file. Now, the last thing we want to try is to see if there are any requests to this IP address. Remember that this IP address resolves to this host. So if any requests were made to this host to retrieve the malicious file, they were actually they should have been made to this IP address, or they resolve to this IP address. So let's now search with this IP address. So destination address, search, and we have a match. Let's have a look. It was originated from, again, Dylan's machine. So here we're going to open it. Please go to the EDR page and contain the user machine. After containment, please click next button to finish the playbook. So we go to Dylan's machine by clicking on the endpoint security here, and we click on contain. Remember that containment is actually more than just deleting the email. In real containment, you're going to have to first delete any signs of this file, Malloy.mp4. Okay, that's the first thing you're going to have to do because it was downloaded and executed. Delete this file from the registry. Any traces left in the temp directory, in the startup, you're going to have to delete all of this. Okay, and that's the only trace left for now. And then you run an antivirus scan, restore from the recent good backup, okay, to Dylan's machine, and then you're good to go. And then you can classify this as a real containment. So then we're going to click on contain, change. So host contained. Okay, what artifacts do we have in here? Now let's go back and have them one by one. So we have a URL here. It is C2. Oops, gonna have to go back. URL C2, and then we add another one here for the file. Usually we add the MD5 hash, or the hash of the payload. But since the file cannot be retrieved for now, we're going to add the file name. So it is stage 2 payload. URL email domain. We don't have file, we have MD5 hash, but I think we cannot retrieve the file. Let's see if the file can, the MD5 is calculated using the logs. We go back to the logs, and here we refresh and we search for using a raw log. Let's have a look. That's the file name, but we do not see any hash. If we try to download the file ourselves, probably it's not going to work. Of course, because the file is down, the domain is down. We can also use the domain name and look it up using threat intelligence in ANY.RUN. Okay, let's have a look at this one. So this analysis session analyzes the request made to this domain name. Okay, that's the file. Now I'm looking for MD5 hash. You can click on the IOCs, and let's have a look at the IOCs that were accessible at the time of analyzing the URL. We have the URL and we have hashes. Now none of these hashes are for the file. DNS requests, connections. Let's search for the file here. We can search for files in ANY.RUN by clicking on files, and here to search for the file name Malloy. So it looks like the file was not even downloaded to the victim machine. So we're going to skip the file and go back to the artifacts. We can add the full URL, not to miss anything from the analysis. So we added the domain name, and we also add the URL. Okay. Also, we're going to add the, let's go back. We need to add the main delivery site. So that's the main phishing site. We can add this as well and say it is URL here phishing site. Still, we're not finished. We're going to have to go back to the log management, retrieve the email address that delivered the phishing site. It was this email. Okay, add this phishing email. Select type. It is the email sender. Okay. Also, we can add the IP address of the server. SMTP IP. Also, we can add the IP address of this domain. Okay, so we're gonna have to click on IOCs here and have these IP addresses over to Letsdefend. Add this one first and add the other one. C2 IP, C2 IP. Select type, it is IP address. Did we miss anything? Also add this domain as well. Gonna select email domain, phishing domain. Next. Okay, next. Finish. And now it has moved to the closed alerts. So now I'm going to click on close alert, and it is true positive. And this was done. Let's have a look at the score. You see all of the answers we have selected were true. Okay, and we are done with this. If you want more information about the Luma stealer, again, check out the video in the description.